this video, we will solve linear expressions with one unknown containing absolute value functions. So our first example problem will be the absolute value of 5x minus 3 equals 2. And we will consider three other variations of the same problem. So go ahead and solve it. Here's my solution. Since we have the absolute value of a quantity equals 2, that quantity could equal 2, or that quantity could be the opposite of 2, negative 2. For both of these, the next step that I would do first is add 3 to both sides. So 5x could equal 5. Divide both sides by 5. And that would tell me that x must be 1, is a possibility. 1 would make the original equation true. But we could add 3 to both sides here, and we could get that 5x is equal to 1. And therefore, if we divide both sides by 5, x would be 1/5. So either 1 or 1/5 will make the, when substituted for x, would make the quantity and absolute value equal 2. It's good to note that the first one would make the quantity inside the absolute value sign equal to 2, and the second one, when we substitute it in, would make the quantity inside of the absolute value sign negative 2. So either one of those will in fact be solutions, and no other numbers would be. Let's consider a variation on that problem that we just did. Let's consider the absolute value of 5x minus 3 equals negative 2. So go ahead and get your solution. This one has no solution. The reason being, what is inside of the absolute value signs could be positive 2 or negative 2, but once we take the absolute value of it, it could not possibly have a value of negative 2 any longer. So there is no possible number to put in for x that would make the expression in the absolute value sign have a value of negative 2. You can never get a negative value out of an absolute value operation. So let's continue onward with two other problems. So the first variation that we want to consider is the absolute value of 5x minus 3 is equal to 2. And the second variation is 5 times the absolute value of x minus 3 equals 2. So go ahead and solve both of those. Here's my solution. For both of these problems, you have to get the absolute value sign operation isolated. So we will add 3 to both sides, and that isolates the absolute value of 5x, and we know that that should equal 5. So now we know that 5x could be equal to 5, so when we take its absolute value it would be 5, or 5x could be the negative 5, since its absolute value would still be 5. Clearly in the first case, x would have to be 1. In the second case, x would have to be negative 1. So x could be 1, or x could be negative 1. Both of those would end up giving us, make a true statement out of the original equation. For the second problem here on the right, we first need to divide both sides by 5 in order to get the absolute value sign by itself. On the left-hand side, 5 divided by 5 is 1, so we have an identity property. Divided by 5, simply 2/5. Now we're down to the absolute value of a quantity on the left-hand side, so that quantity must equal what's on the right-hand side, or that quantity must be the negative of what's on the right-hand side. Because if x minus 3 is equal to the negative of 2/5, when you take its absolute value, it will be 2/5. So let's now add 3 to both sides. So x is equal to 3 and 2/5. If you want to, you can call that 17/5. We do the same thing over on the other option. X would be 3 minus 2/5, which you can't write as a mixed number that way. So we have to call that 13/5. Or if you prefer, you could call that 2 and 3/5.